4.5 is graphing other trig functions, and this first part we're going to start with is tangent. And tangent, the thing that we need to kind of remember is that when we were using this triangle, tangent was the TOA. So it was the opposite over the adjacent. Using this triangle, if this is theta, then tangent of theta would be y over x. Well, there's a problem with this because whenever you have a fraction and we're dealing with this fraction y over x, tangent's going to be undefined. It's going to be undefined whenever x is equal to 0 or whenever cosine is equal to 0. These mean the same exact thing. And what that is those are the asymptotes. In class, we drew with every single problem that we graphed. We always drew this, which related back to the unit circle. And these were our x and y values. These are easy to figure out what tangent is because you're going to be dividing by ones and zeros. So it doesn't take too much to figure them out. However, we really could go in throughout the unit circle and find any of the values. For example, we could find pi over 4's tangent value if we wanted to. It would just be the square root of 2 over 2, square root of 2 over 2. So this is using our unit circle. We found this point from the 45-degree angle, or the pi over 4. And we would just divide y by x, so divide this by that. And if you notice, they're both the same number. So in this quadrant, tangent would be positive 1. Over here, you would have the same two numbers, only your x value would be negative. So still going to be dividing the same numbers by themselves, only with that being negative, this would be a negative tangent, negative 1. Down here in this quadrant, it would be positive, because you'd have both of them being negative because your x and your y's are negative. And over here it would be negative. We're not going to use that value just because we're just sketching tangent and cotangent, but you could if you wanted to. It would not be wrong. Okay, so every one of these, we're going to be graphing these same angles. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And tangent was y over x. So we wrote that a gazillion times, hoping to try to get that into our brain and we don't forget it. And then we just use this, oops, that's an x. We just use these points to go around the circle. Okay, so the first one, the y value is 0, the x value is 1, so that's 0. Pi over 2, I'm up here where that second check mark just went in. That would be 1 over 0, so that would be an undefined. Pi right here would be 0 over negative 1, so that's 0. Down here at 3 pi over 2 would be negative 1 over 0, which is undefined. And then back at 2 pi or 0 would give us, all the way around the circle, would give us 0 over 1, which is not 1, it is 0. Okay, so what do we know? Well, you're going to have to go back and look at your table that you just filled in, but what we do know, I might open up my notebook just so I have it to look at, makes it easy to graph. But as we're graphing this, we have pi over 2, pi, 3 pi over 2, and 2 pi. And I'm also going to do the negative. We had all our asymptotes were at pi over 2's. and that would also be in the negative direction. And the other values were our zeros, and those were at all, if you noticed on your table, were all the pies. Okay. I'm going to tell you tangent looks very similar to a cubic. It follows the asymptotes, like so. Okay. If you notice on this graph, which I don't know if you're going to pay much attention to, let me use this highlighter. I'm going to look at this right here. This is one between pi over 2 and 3 pi over 2. This is one wave or one cycle of pi, one period of tangent. If you notice right here, from pi over 2 to pi, and from pi to 3 pi over 2, these are both half of a pi. If you have half of a pi plus half of a pi, that would give you one full pi. So my period is pi. So to figure out the b in the transformation equation, instead of having 2 pi over b like you did with the other sine and cosine, you're going to have pi. Weird way of listing it, but this is how your textbook does it, and I'm going to kind of break it down just a little bit easier for us. But my zeros, if you notice, were all the pi values. And so how you write that is plus or minus n pi. And what n stands for is an integer. And it's a number, both positive and negative. And it just, meaning you're going, let me just put this, n is equal 0, blah, blah, 1, comma, 2, 3. So this is saying 0 times pi, which would be 0, so that would be that value. 1 times pi would be here, because that's 1 pi. 2 times pi would give you 2 pi. And then going in the negative direction, this would be negative 1 times pi, negative 2 times pi. Now on your quiz, you might see something where I'm just asking for the interval from 0 to 2 pi. Just list all those zeros. And that would be from x is equaling 2 pi and 2 pi. Oops, and you're going to have to list one that I just forgot, but I added it in. My asymptotes, if you notice, those are at pi's over 2's. How you can include every single one of those, that's x equaling, is by adding pi, multiples of pi. So if you had pi over 2 and you added a complete pi, you'd be over here at 3 pi over 2. If you added another complete pi, you'd be at 5 pi over 2. Now on your quiz, you might, or test, might just see, well, tell me all the asymptotes from 0 to 2 pi. And that would be x is equal to pi over 2 and 3 pi over 2. There are no breaks in my range, so this would be negative infinity to positive infinity. And my domain would be, it's going to be related to this, your asymptotes. And it's basically the quick way. You can use set notation, but I think for our class, we're just going to say x can be every number except for x can't be pi over 2 plus or minus n pi, which is all the multiples of pi. That'll give you all the asymptotes. Now, the symmetry, if you remember from first semester, this is odd because if you were to pull this side and this side up, directly up, if you can picture it directly up and bending them over, these would be symmetrical on the origin. Okay, cotangent, similar concept, same, same similar concept in which we're going to go in and, hold on, let me get that little part off there. I use the Doceri for this. You're still looking at cotangent using this triangle. You've got y and you've got x and you got r. And cotangent is your your adjacent over opposite. So cotangent using this triangle would be x over y. Just the flip of cotangent. So cotangent would be undefined whenever y is equal to 0 or sine is equal to 0. And what does that mean graphically? That means they are, I was going to spell asymptotes incorrectly. They are asymptotes. You're going to do your same angles that we've been doing all along. You're welcome to do more if you need to, but we're just sketching, so these will give us the zeros and they will give us the asymptotes, and then we're going to sketch along. Cotangent is going to look very similar to tangent, only it is not going to go through the origin. And I know I talked about in class, if you have a situation like this where you have a negative in front of tangent, tangent looks very similar to cotangent in that it's going the other way than what the graph we graphed. So tangent, I'll put in yellow, positive tangent would be going this way. And you're going through the origin. Negative tangent goes to the origin, but it is graphing the flip to that. It's flipped over the y-axis. Tangent is going to look pretty much like that negative tangent, or cotangent is going to look pretty much like negative tangent. The only difference is we do not go through the origin, so that's how you tell the difference between the two of them. Okay, cotangent is x over y. Same graph that you have, so I'll just kind of sketch it real quick. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So at 0, it will be 1 over 0, so that's undefined. Then at pi over 2, it's going to be 0 over 1, so that's 0. At pi, it's going to be, excuse me, I got that mixed up. It's going to be negative 1 over 0, so that's undefined. 3 pi is going to be 0 over negative 1, which is 0. And 2 pi is 1 over 0, which is undefined. So my asymptotes are on pi's this time versus pi over 2. Okay, cotangent has the same period, which is pi. And let's get all these written down. So this is pi over 2, pi, 3 pi over 2, and 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. You have asymptotes, which I might have to do a different color. At all the pi's. So these are going to be where your x's cannot be equal to. So this will be affecting your domain. And then all your zeros are right here. And just like I was talking about, it's going to look pretty much like a negative tangent would look. It's the flipped of that cubic. Okay. So my zeros are at x equaling pi over 2 plus or minus n pi. If I were to put it on the quiz, it would be like, give me the interval between 0 and 2 pi, and that would just be x is equaling pi over 2 and 3 pi over 2. Your asymptotes would be at plus or minus n pi. So if you had to do the interval on your quiz, it would be x is equaling pi and 2 pi, and once again I keep forgetting the 0. Your range is still negative infinity to positive infinity, are all real numbers. Your domain is going to be all your values except, and like I said, you probably should do set notation, but all your numbers except for your x values at n plus or minus n pi. And this guy is also odd, because if you were to pull this one up and pull that one up directly up, they would bend right into each other, which is an odd function. Even folds, it's symmetrical on the y-axis, and this is odd as on point. secant and cosecant, we're going to be doing the same things. The big thing you need to remember is this is the inverse of cosine. So one thing I kind of do when I'm graphing these, and I do this every time, I graph cosine and then I use that to help me graph secant, and then I just erase cosine when I'm done. But I'm still doing 0, pi over 2, pi, 3 pi over 2, and 2 pi. Secant is your hypotenuse over your adjacent, that's a C. And so using the triangle we have there, it would be R over X. The great thing is your unit circle is 1, so your R value is 1. So you just take all of your values and put them over 1. Your X value is your cosine. So secant is going to be undefined whenever X is equal to 0 or cosine is equal to 0. And that would give you asymptotes. Okay. So you have your triangle, or you have your unit circle. So you got 1, 0, 0, 1. They were getting really tired of drawing this in class, but it's good practice, and you're not going to forget it. So this is going to be 1 over x, 1 over x, 1 over x, 1 over x, 1 over x. So 1 over 1, 0 degrees would be that. Pi over 2 would be 1 over 0, so there's your undefined. Pi would be 1 over negative 1, which is negative 1. 3 pi over 2 would give you 1 over 0, which is undefined. And then 2 pi would give you 1 over 1, which is 1. Okay. Just like sine and cosine, the period for secant and cosecant are both 2 pi. And I'm going to first graph cosine. Actually, let's put our asymptotes in first. So our asymptotes for secant were at pi over 2. Okay, so cosine starts at 1, goes to 0, goes down to negative 1, goes up to 0, and goes back up to 1. And it's going to do the reverse going the other way. So I've got 0, 1, 0, back up. So it's doing this. Hopefully yours looks a lot better, because that really doesn't look very good. So the actual graph looks like this. So this is the actual graph. So these were the zeros. Let me get that a little bit bigger. These were not the zeros because cosine and secant, or secant and cosecant don't have zeros. But these were the values when they were at 1 and negative 1. What I do is when your hump or your wave is up near 1, you draw a parabola going up. And when it's down, you draw a parabola down. Like so. And then you erase your cosine, because this is what the actual graph is. Okay? So your domain is everybody, well, let me do your asymptotes and your zeros. So you have no zeros. Your asymptotes are at pi over 2 plus or minus n pi. which would be your domain. It would be everybody but pi over 2 plus or minus n pi. Your range is a little bit different because your range goes from negative infinity to that value, which is -1, and from 1 on. So negative infinity to -1, union 1 to infinity. And if you notice, you're symmetrical on the y-axis, so this is even. Okay, cosecant is going to be the same concept, only it's now sine. So 1 over sine, so that means you're going to be 1 over your y value. So cosecant, and I can't do that, right? Cosecant theta would be equal to r over y, which is 1 over y. Cosecant will be undefined when y is equal to 0 or sine is equal to 0, and those would be your asymptotes. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And that would be 1 over, oh, probably should draw this because it focuses me. Otherwise, I kind of have to see if I can remember what those values are. You do have your unit circle, so you would be okay. Okay, so 0 or 1 over y, 1 over y, 1 over y. And start up here, so that'd be 1 over 0, so that's your undefined. That would be 1 over 1, which is 1. That would be 1 over 0, which is undefined. And that would be 1 over -1, which is -1. And 1 over 0, which is undefined. You might want to pause because when I hit this button, it all goes away. Although it's taking a little bit more time. There it is. Okay, so when we go to the actual graph, the graph's going to look like, here we go. So we have pi over 2, pi, 3 pi over 2, and 2 pi, then the negatives. And like I did before, I'm going to graph sine. Sine starts at 0, 0, then it goes up to 1, then it goes down to 0 to pi, which is 0, then it goes to -1, that's a negative, and then it goes back to 0. Since I'm right here at 0, this is going to put me back down at negative. Just got to finish the thing, go to 0, go up to 1, and back down to negative. So this is sine. My asymptotes are at the pi's. So that would be and your actual answers, if you notice, these happen to be the 1 values and the negative ones. So you just follow the asymptotes. When your parabola is up, you go up. When your parabola is going down, you go down. And then you actually go in and erase sine. You have no zeros. We are still 2 pi is our period. Kind of going in a weird order. I would actually be odd here because if you were to pull this one up and this one up, you'd be symmetrical along that. My range is kind of weird, but it would be from negative infinity to negative 1. That's a bracket. Union 1 to infinity. My asymptotes are at x equaling plus or minus n pi, which would be related to my domain. X cannot equal anybody, can be everybody but these values, all those pi's. All right, all done.